Okay, I had a student here who's got a part that would be perfect for a demonstration for using sheet metal, SolidWorks sheet metal. SolidWorks is one of those designed for manufacturing sort of toolbars where you could actually not only model a part, but you model a part that actually can be manufactured using sheet metal tools. So the desire here is this part was actually created in a different way, not using sheet metal tools, but we can convert this if we kind of play around with this a little bit, and I'll show you how to do that. But essentially what you're going to do ultimately is you're going to get a flat pattern like this. And the sheet metal operator is going to go ahead and cut this out with all the holes and stuff like that in there. And you can see that we have lines in here that are going to show it where the bend lines are going to be. So it's going to put that in some sort of jig. It's going to bend it along that bend line at a specific radius. And ultimately you're going to get a part that looks very similar to the part that we are going to model or have modeled. So when we unflatten it, this is what we're going to get. Not quite the same as what we have up front, but it's actually something that is manufacturable. So how do we do that? So let's go back to our original part over here and see what we could do with this. Okay, so let's see what we could do. This is how you do the sheet metal thing. With the sheet metal tab open up here in the command manager, if you can't find that, what you do is you right click up here and you just click or check mark one of these items in here that you might want to have show as a tab in your command manager. But we have sheet metal up here, so we're going to go ahead and choose convert to sheet metal and see what we get here. So we're not going to use the gauge table, so from the top to the bottom is asking up here to select a fixed entity. So in other words, what we're going to do is we're going to select maybe the bottom face of the stapler reservoir here, and everything is going to bend to that. So we're going to bend this side over here, bend that side over here, and bend these two tabs in the front. And we're going to do it that way. So we're going to go ahead and choose the bottom down here. And then we're going to go ahead and choose our parameters. So in regard to this fillet over here, it's 0.05 on the inside. But it always considers when you put in a value in here, the minimum value. So it's not going to, you can't put a 0.05 on the outside where it actually comes down to 0 or less on the inside. It's not going to let you do that. So when it talks about the radius in here, you're going to put in the minimum radius. So it's 0.05 inches in thickness over here, and this is a 0.1 fillet. We're going to make that 0.05 for the radius in here. That's going to be the fillet that's going to be in the inside when it creates that. So that's going to be the radius, and the thickness of the material, we're just going to emulate the thickness of the material that's already there and go ahead and do that way. So we're going to ignore these options in here. Now it's looking for a bend edge. So if you click on that edge over here, you can see it's going to try to bend along that. If you click on this edge over here for the other bend edge, you can see it's going to bend along that. And what we really want to do is we want to include these tabs up here too. Essentially what we want to do is we want to see a yellow preview for everything. So if we click on that for that bend edge, and this bend edge over here, giving us a preview for the other one, but not for that one. Let's go ahead and see what happens with that, because we might have to go back to our model and kind of clean that up a little bit. Well, that's not bad. We kind of got close. Let's go back into that. So what that does is it creates a sheet metal folder in here with a lot of our parameters in here. If we were to right click on that, you'll see a very similar window that we had before. And we're just going to go through the default items in here because we could spend all day with sheet metal. But it's going to give us a K factor, which means it's going to take the model. Every time we have a bend edge, it's going to bend it right in the middle, so that the inside of the bend is going to be in compression, the outside of the bend is going to be in tension, and so on and so forth. So that's in that folder, and then we can go into this folder over here and actually make some modifications in here too. And these are all items that are going to perpetuate throughout the design. So here we are down here to the convert solid. We're going to go back into that and go ahead and change some of these items in here. So for this bend edge, we're going to go ahead and choose this one over here, that edge over there. Not going to let us do that, doesn't really like it. So let's go ahead and go to the red X, and let's go ahead and convert that solid, and let's go ahead and delete that. Let's go ahead and select it, and we're going to go ahead and delete it. Now we still have a sheet metal folder in here with some of our basic parameters in here, but now we're going to go ahead and clean up our model a little bit. And since we don't really need fillets in order to put our convert sheet metal model together, we're going to go ahead and delete those. So let's go up here to this bottom cut fillet is probably okay. I had to rename some of these because the student did not name these for me. So it's kind of easy to be able to go through this and maybe rearrange the furniture to put all these like items together. So the bottom cut fillet is probably okay, and I'm going to take that bottom cut fillet, move that up here with the bottom cuts, kind of put that together. Our side slot cut over here, if we want to have that cut before we actually bend it, we're going to go and keep that together with our side hole cut, or cut hole. So we're going to keep that. What else do we have? So this one, the outside fillet, we're going to go ahead and suppress that, maybe just eventually delete that. Something else I did too, this chamfer which was in there. Sheet metal doesn't like chamfers very much, so we're going to go ahead and delete that ultimately. But we're just going to take that chamfer for now. We're just going to go ahead and suppress that and get that out of there. So now we're kind of looking at the basic parts. Something else I added here too was this cut. We're going to have that cut in there unless we want to have a rip corner on one side or the other and just have this as one big door instead of kind of like a Dutch door or French door where they kind of swing open from either side. So I put in this little cut in here, and you'll notice that I call that new front cut. So you're going to have to put that in there in order to divide the model up. So yeah, let's take a look at the top. Top was done, and we did the shell, a basic rectangle for the shell. Let's take a rollback bar and take a look at our model. So if we roll that up here, we put that together with the dimensions that you see, and we shelled it to the outside. So now these dimensions that we had in there are going to represent the inside of the model. It's probably easier to have it measured from the outside, but that's one way to do it. Then the student's front cut in here, and then the outside fillet, we're going to go ahead and delete that. And then we have a staple cut in here, and then the chamfer, we're going to go ahead and delete that ultimately, but it's just suppressed for now. I'm going to take that front cut too. We're going to put that underneath this front cut. Doesn't really, oops, look at that. It goes all the way to the back. So let's go ahead and redefine that. So I have it going up to next in this one, but let's just give it a specific distance. We'll go blind, and we're going to go 1/10 of an inch. 0.05 inches actually. So we're going to go to the green check mark. So then we have our staple cut. That's the student's cut. We put that in there. You want to make sure you put that in there now without being encumbered by fillet radiuses. Then we have a bottom cut in here. And then with the bottom cut, we have the bottom cut fillet. So far everything looks good. And we have our back cut. So the back cut kind of opened up the back here. You have our side slot cut and our side cut hole in the back. So these two items down here are what we have for those. And we're back to sheet metal and our flat pattern. We're going to talk about flat pattern here in just a moment. So I think we're ready to go back and convert our model into sheet metal. And if you remember, we tried to do this before, but now we have a sheet metal folder already here. If we were to initiate this from the very beginning, that sheet metal folder would be at the top of our tree. But inside this folder, if you go in here, we can see some of the basic parameters that we're applying to the whole model. And those include fillet radiuses or bend radiuses are going to be 50 thousandths of an inch, 0.05 inches, and then 0.05 inches for the thickness. We're just using the model geometry that we have, but we could change that. We could actually make it thicker or thinner and change the radiuses on this too for the fillets or for the bend radiuses. If we want to do that, we could do that here and it'll change our model, but kind of keep the same pattern that we have, the same form that we have. K-factor implies that we're going to bend it right there in the middle. And then our auto relief right now, I think it's set for rectangular, but it could be tear or oblong, but we'll probably cover that in a different video. So we're going to go to the green check mark. We're going to stick with the default settings that were given us, and then we're going to go back to convert sheet metal. Kind of like what we did before, we're going to go ahead and choose this bottom face down here. And here, these are grayed out because we've already defined those elsewhere. And then we're going to go to our bend edges, and we're going to go ahead and choose this edge over here. And if you look at this real close, you can see that it's putting in that bend in there, both the inside and outside, kind of like a fillet radius. And we're going to go ahead and choose this edge over here, and that's going to do the same thing. It's going to bend that. And because we chose this as our neutral face, as our fixed face, everything's going to bend around that. So when we flatten this out, this side's going to bend over here, that side's going to bend over there, and these doors are going to open up out front. But that's going to stay fixed during the whole thing. So bend edges, one more time, we're going to go ahead and choose this edge over here. So you can see how that's going to do. You can see how that's going to resolve itself. And now we have something different. We have a ripped edge. So we can probably force that. We could define that a little bit better, but by default it's going to go ahead and select this edge down here, and it's going to have to take some material out in order to make this fit, and that'll become apparent when we actually finish this. So our last edge over here is going to be this one, and again it's going to take out a portion of that edge down here, and it's going to rip that out, and you can see the bend in here. So now we can go to the green check mark, and there we have it. There's our part converted to sheet metal. Okay, so you're probably looking at the model saying like so what? It kind of looks like the way it did before. Maybe it's a little bit more realistic. Maybe it's not. But what we're doing is we're actually defining how this thing gets manufactured. Not only are we showing the form of a product here, we're kind of implying how it should be manufactured. And I'll show that to you in just a moment. So we can continue to make modifications here. If we were to go into our sheet metal folder and go to some of the parameters in here, maybe the filleted radius or the bend radius is in here were a little bit too big, and we want to change that, we could do that here. We'll go ahead and change it throughout the whole model, which is kind of a nice little feature. So now it's a little bit tighter than it was before. And ultimately what we want to do is we want to get down to a flat pattern. So we're going to define how somebody's going to make this. And the way you start with this is you start with a piece of sheet metal of a certain thickness. You put your cuts, you cut it out, you put in your cuts for other items in here, and then you tell it where to bend and what the bend radius is going to be and everything else, and that's how you get your part. And the way you get that here in SolidWorks is you go over here to the bottom of the tree. There's a flat pattern folder in here. If you were to right click on that or open that up and right click on the flat pattern number 10, I think it's what it says, yours might be a different number, we could actually unsuppress that. And when we do that, you can see in green over here what are going to be eventually going to be the bend lines. So we're going to unsuppress that, and there's our bend lines. You can see them in gray in the background, and you can see our part is flat. So the first thing they're going to do when they manufacture this is they're going to stamp this out, put in these cuts, put in these holes back here, put in the bend lines. You're going to put it in the machine, it's going to bend it, and it's going to get our part ultimately. So if you open this up even further, now you can see our bend lines highlighted in green. And then you have your bounding box, which tells you the extent of the part. So if you want to take that part and if you want to actually measure it, you know how big that piece has got to be. So we can go up here to evaluate. We can measure like between maybe this line and this line over here. It'll give us a distance 1.56 inches, and maybe that line in the back we could do the same thing back there too. That will give us the length and width of our box. So that's 1.56 inches, and this one's got to be 6.23 inches. So what does this look like? I mean, if we were to actually take each one of these items in here and then suppress them, if we suppress the flat pattern, it's going to show us what it's going to do. Maybe incrementally, it's going to show us how that's going to be cut and reformed. So we could do that. Unsuppress each one of these, or suppress each one of those flat features, and you can see how it's going to bend. This is just one way of doing it. But you notice that when it does bend or unbend, it's going to do that on each one of those bend lines. So remember the K-factor. The K-factor is going to tell us that we're going to be bending right in the middle of those lines. So let's just try that one more time. We're going to unsuppress that, and if you look at that bend line and look where that bend line is just about right there in the middle of this. So if you were to project that forward, to be right there in the middle. So let's go ahead and unsuppress that, and let's go ahead and suppress this feature, and it's going to go ahead and take what was flat before, it's going to make it whole. And the way you do this is just go back and forth between that, suppress and unsuppress that. You can go back and forth between the flat pattern and the folded pattern. So that's kind of like sheet metal in a nutshell. That's how you take a part, and that's how you convert it to sheet metal. So what that does is it provides you with a sheet metal folder with the basic parameters which define all the elements that are necessary in order to make your part within the whole folder, within the whole part itself. That's your sheet metal folder. Then you have your convert sheet metal item in here, your feature over here in your feature manager. And within that you have your bend and unbend patterns and all the other elements that go with that, including your bend lines and the bounding box. And from there you can go ahead and create a flat pattern, which you can import into a drawing, or send that out as a 3D model for somebody to actually manufacture for you. But ultimately, the bottom line for sheet metal is you're defining not only the size and shape of your part, but you're also defining how that part could be made.